Hello and welcome. So today we will help Mario save the princess that is on top of this thing. And we have these stacks, these piles, they are unsorted. And if we sort them, Mario can go up and save the princess. So we must sort them using selection sort. She is screaming for help.
Help, help, help.
As you can hear, and also she is crying a lot. And these tears will make the river go up and the monsters can go and get the princess.
Time is running out.
Mario have this computer that helps him switch these stacks, these piles, okay? And also he has this piece of paper with 3 variables, I, j and min. All are indexes, and you can see the index of the array here. We have the index is the second row, 0, 1, 2, 3, 4, 5, 6 and 7. The value is the number of blocks of each stack. So these have 14, these have 5, 9, 3, 1, 15, 12 and 8 blocks, okay? Mario starts here in the first index, the number 0, and he puts the number in the I and min variables. After this he goes to the next index and inserts in the j. Because 5, the number that is on the index 1 is less than 14, the number that is on the index 0, we have to put the 1 index in the min variable. Then Mario goes to the next index, and we have a 9 is not less than 5, so he proceeds to the next position. The number 3, he updates the j with the index 3, and he finds out that it has the value 3 too. So 3 is less than 5, the number that is at index 1. Okay, so he have to update the min with the index of the j, so he inserts number 3 in min variable. Then he goes forward and he finds the number 1. The number 1 is less than 3, so he have to update min with the index of the number 1, the index 4, so he updates that. He goes forward, 15 is not less than 1, and 12 is not less than 1 again, and 8 is not less than 1, so he is ready to do the switch. He goes to the machine, and when he arrives, he computes in the machine that he have to switch the values of the index 0, this index, with the index 4, this index. So 14 will switch with the number 1. They change and they swapped. So we have the number 1 here and the number 14 here. Now Mario will do the next search. I, instead of searching from the index 0, will start at index 1 because the index 0 is already sorted, okay? And the j always starts one position after the I, so it will start at index 2, okay? And he finds out that 9 is not less than 5, so he proceeds. And now he finds that 3 is less than 5, so he have to switch the j index here, and min was updated with the number 3, the index where the number 3 is. He goes to the next index, 14 is not less than 3, 15 is not less than 3, 12 is not less than 3, 8 is not less than 3, so is ready to compute and switch the values. So he will switch the I equals 1 and min equals 3. I equals 1 is this index, the 5, and min equals 3 is index 3. So we'll switch 5 with 3. And is switched. These two numbers, these two positions are already sorted, 1 and 3. Now it starts at the index I equals to 2, okay, and j will be the next position, 3. Because 5 is less than 9, min is pointing to the index 2, where we have 9, j is pointing to the index 3 where we have 5, so 5 is less than 9. We have to update the mean with the number 3, the index where 5 exists. He goes forward, 14 is not less than 5, 15 is not less than 5, 12 is not less than 5, and 8 is not less than 5. So he goes and will make the switch again. Switch 2 and 3 and 5 and 9. Okay, moving forward, there is no time to lose, and it starts with I equals to 3, j is in the next position of I, and 14 is not less than 9, so it proceeds. 15 is not less than 9, 12 is not less than 9, and 8 is less than 9. So we have to update the mean with index found in the j. So he updates with this value and is ready to switch in the machine. And he will switch the index 3 with the index 7, these two, and switch it. These 4 positions are already sorted. He goes to the next and he finds the index 4 and he puts in the I and in the mean, and j in the next position, the index 5. 15 is not lower than 14, so he proceeds. 12 is lower than 14, so he have to update the mean with the value of j, and he updates. He goes forward, and 9 is less than 12. He have to update the mean with the index of j, the number 7, so he updates again, and he is ready to switch in the machine. He goes, runs, and switch 4 with 7, these two, and now these are all sorted. So we will start at position 5. I is equals to 5, index j is equals to 6, and 12 is less than 15. 15 is the position of mean, so he will switch mean with 6, the number that we find in the j, this position. He goes to the next, and 14 is not less than 12, and is ready to update again. We'll switch 5 and 6. He goes to the next and inserts in the I the number 6, in the j the number 7, and by the way 14 is less than 15, so he have to update the mean with the number 7, and is ready to switch, and goes and switch the index 6 with the index 7. So there was just one position left, okay, and we know that the array is already sorted, so Mario can save the princess, finally. Now we have our conclusions. Selection sort is very inefficient on large lists. Why? Because if this is very big, Mario have to run a lot, and it requires a lot of processing power. The only advantage for Mario is that it doesn't have to go to the gym, but for the computer it have to do a lot of processing. It consumes a lot of processing power, okay? Another thing is selection sort compared to other sorting algorithms is very simple. I think is the most simple algorithm for sorting. So because of this simplicity, it has performance advantages over complex algorithms when we have a scarcity on memory. When we don't have too much memory, the selection sort can be better than the other algorithms because it requires so much less memory. It just keeps tracks of 3 variables, the 3 indexes here, and when we have to do the switch thing, just that. Other algorithms needs a lot of more variables to work, and in that situation, when we don't have too much memory, selection sort can be better than the others, just because of that. This is the end, and as always, thank you for watching.